Allow me to present to you today's moderator. Morgan Zabo is the Community Heat and Health Information Coordinator with NOAA's Climate Program Office. In this role, she co-leads an interagency heat communications team, which includes large-scale federal social media campaigns and creating infographics and messaging for heat preparedness. She also leads NOAA's community science urban heat island mapping campaigns, where she works with community members and organizations across the country and internationally to map the hottest parts of the communities in hopes of implementing solutions for those who are most disproportionately impacted by heat. Morgan has a Master's of Public Health in Environmental Health from Emory University and a Bachelor's of Science from the University of Georgia. With that being said, Morgan, I give you the floor.
Thank you so much, Gideon. Hi, everyone. It's a pleasure to be with you all today. This is an incredibly timely webinar, and so I know that my colleague and good friend Amber has a lot of really great content for you. So, Amber, I'm going to go ahead and introduce you if you're all set to go. Amber Liggett is a communications analyst for Groundswell Consulting Group, working as a federal contractor for the National Oceanic and Atmospheric Administration, or NOAA's Climate Program Office. She's also a science writer and a public speaker for weather, climate, emergency preparedness, and disaster sciences. Amber obtained her Bachelor's of Science in Meteorology and a Master's of Science in Emergency Management from Millersville University of Pennsylvania. She strives to work in both fields throughout her career. Formerly, Amber was concurrently the Pennsylvania Department of Public Health Information Officer, working in public health emergency preparedness and response communications, and a freelance broadcast meteorologist at the Harrisburg, PA ABC affiliate. Amber incorporates arts into science, technology, engineering, and math through her award-winning business, Amber's Amazing Animal Balloons, which has been a proud Weather Ready Nation ambassador since 2017. She demonstrates how balloons are an important tool for measuring weather elements while creating weather-themed balloon art and sculptures. Amber, I turn it over to you.
All right, thank you, Morgan, and thank you, Gideon. Good evening, good afternoon, depending on where you are, everyone. Thanks for being here. Really excited to talk to you today about, again, this very timely topic about staying cool with the heat this summer and also talking about heat health. All right. So as we go through today, we're going to kind of start off going through some of our recent and current events and then getting into planning for heat, talk about some of the different things you can learn about heat waves and health impacts, and then we're going to finish off with some heat wave actions. Starting with last year in 2023, it was actually North America's warmest year on record. And it was also South America's warmest year on record. And really, in Europe and Asia, it was their second warmest year on record. So it was a really warm year, and we're probably going to break that record here in 2024. Also looking at our land and ocean temperature percentiles for last year, 2023, the global surface temperature was 2.12 degrees Fahrenheit above the 20th century average. So this, again, was the warmest year on record, and the second warmest year was actually 2016. But I will point out that the 10 warmest years that we've seen since 1850 have all occurred in the past decade. Now coming up to this summer, June 2024, here in North America, it was the fourth warmest June, and really the second warmest January through June, so the first half of the year on record. So again, we're looking to see that this is going to probably be another record-breaking year, but at least for June, it has already broken a record. And coming even closer to home, what we're starting to see are different states tying and breaking heat records, especially in June. So according to the Weather Service, on June 17th, Chicago, Illinois, Pittsburgh, Pennsylvania, Indianapolis, Indiana, Milwaukee, Wisconsin, Cleveland, Ohio, Syracuse, New York, Louisville, Kentucky, and Fort Lauderdale, Florida, all tied or broke records. So if you recall, there was a huge heat wave that did occur in the eastern half of the country in June, and those were just a few of the records broken. Then on June 18th, there was about a 3-day major heat wave where we saw a lot of records. In Manchester, New Hampshire, and Scranton, Pennsylvania, there were records broken again on June 18th. And then on June 19th, Boston, Massachusetts hit about 98 degrees Fahrenheit. Hartford, Connecticut reached 97 degrees. That was only in June. As we moved into the beginning of July, we saw even more record-breaking heat across other parts of the country. On July 5th, records were broken in Charlotte and Greenville areas of North Carolina. Then on July 6th, many cities in California were breaking their temperature records, including Sacramento City, Stockton, and Redding. And Redding actually was at 119 degrees, which beat the previous record of 111 degrees in 1984. And it also beat the 118 degree all-time high temperature record for Redding. July 7th, Las Vegas broke multiple records, including daily highs and all-time high temperature when the city hit 120 degrees Fahrenheit. The city also broke the record for the most consecutive days over 115 degrees Fahrenheit at 7 days in a row. And then on July 8th, Reno also broke records, and we were seeing that in Oregon, there were several cities, including Portland, Hillsboro, Salem, and Eugene, which broke records, as well as Lewiston and Omak. And those two were the hottest spots, reaching 107 degrees. It didn't stop there. As we continued on in July, Seattle beat the daily high temperature at several monitoring locations on July the 9th. And also July 10th, we had high temperature records in Baker City, Oregon, Boise, Idaho, and Mountain Home Air Force Base, Idaho. So that's just some of the stats for June and July. Another big stat you might have heard is that we did achieve our hottest day on record across the entire Earth last Monday, July 22nd. This is more on the climate scale. So according to the European Union's Copernicus Climate Change Service, the hottest day recorded on planet Earth was on Monday at 62.87 degrees Fahrenheit. And this analysis is really indicating that we have a sudden rise in daily global average temperatures this month, and that's related to well above historical average temperatures, especially over Antarctica, and that's continuing to break records for low ice extent. And if you think about it, North America has a lot more land, and the northern hemisphere, I should say, has a lot more land, and the southern hemisphere is full more of oceans, and so the northern hemisphere is heating up a lot more, and that's also contributing to why we're seeing these warmer temperatures. But not just July 22nd was the only day last week that had people talking. Also, July 21st and 23rd exceeded previous daily records that were set back in July 2023. So preliminary data is calling these the 3 hottest days on record. And I will just note that when we're talking about the record, that started back in 1940. And in general, the last 10 years have been the hottest. We've seen the hottest day ever in the last 10 years, going back to 1974. That's what we're seeing on this graph here. But before July 2023, the previous daily global average temperature recorded was 62.24 degrees. So that just gives you an idea. That was all the way back in 2016, as I was showing you those maps and telling you previously when we did see some of our warmest times of the year. So overall, of course, things are heating up. And when we take a look at the Climate Prediction Center's seasonal temperature outlook for the next 3 months, you'll see that really we're looking at above normal temperatures across the majority of the contiguous U.S. There is a little bit of uncertainty across the northern plains and into the center of the country, especially where we might see some La Nina impacts, but that is what the Climate Prediction Center is showing. You'll also note that the south part of the United States is typically seeing the peak average temperature during the second half of August, and the West Coast is seeing the hottest temperatures usually into September. I'll also note that climate.gov is publishing their August outlook tomorrow, so you can go ahead and look out for that. So again, those were just a few. There's so many, but a few stats from some of our more recent and current events that we're seeing when it comes to heat. But how do you actually plan for extreme heat. So we're going to get into some of the different tools you could be looking at and some other information that'll be useful. Starting off with a few tools from the National Weather Service: heat index, wet bulb globe temperature, and heat risk. Now, the heat index tool is probably the one you're most familiar with. It's a measure of how hot it feels when relative humidity is factored in with the actual air temperature. And if you're going to find what the heat index temperature is, we can go through an example here on this chart. So let's say that the air temperature is about 96 degrees Fahrenheit and we have humidity of 65% relative humidity. So if you go down, you're going to hit 121 degrees. And again, that would be the feel-like temperature. This is showing that it's a dangerous temperature if you look down here at the key. But all these areas in red, especially those that are without numbers, are showing extreme danger. And so the National Weather Service will initiate alert procedures when the heat index is expected to exceed 105 to 110 degrees Fahrenheit, depending on your local region, for at least 2 consecutive days. Now, heat index values were invented for shady, light wind conditions, but exposure to full sunshine can increase your heat index value by up to 15 degrees Fahrenheit. Now, this is kind of showing some more information about the heat index, but you'll see that I've highlighted the box of limitations and concerns or other considerations, for example. So it's not the best indicator of areas that are with low humidity. If you are an outdoor worker or you're playing sports and you're doing a lot of activity outside, it's not really going to give you an accurate measure of the heat impacts when you're doing those activities. And again, it is calculated for shaded areas. If you are in full sunshine, you are probably going to be feeling a heat index up to about 15 degrees Fahrenheit warmer than that. Next is the wet bulb globe temperature, which uses temperature, humidity, wind, solar radiation, and some other weather parameters. And what you see in the picture is an example of the equipment for it. And temperature is a combination of the outputs from 3 different thermometers when we're talking about wet bulb globe temperature. So you have this black globe here for sun angle and cloud cover. You have the wet bulb for humidity and the dry bulb for ambient temperature. Now, the wet bulb globe temperature is particularly effective it's an indicator of heat stress for active people. So while we said you're probably not getting the most accurate feel-like temperature with the heat index, you would if you are an outdoor worker or playing sports with wet bulb globe temperature. Same kind of chart here and looking at some of the limitations and consideration. So because the values are typically lower than the heat index, there's sometimes a perceived lower risk when you're looking at wet bulb globe temperature. Also, the heat stress categories do vary depending on your climatological location. And the threat level color scale here that you can see that I've added on here, it's also broken out by region. And so that's something that you have to keep in mind. And in general, as I just went through and explained it, it does take a lot more context to understand how this tool works. The most recent tool, this is an experimental tool, the National Weather Service Heat Risk tool. It's a forecast that provides a color and numeric value that places forecasts heat for a specific location into an appropriate level of heat concern. It also identifies groups that are potentially most at risk at that level. And it is accompanied by recommendations for heat protection. It's a useful tool also for planning for upcoming heat and associated potential risks. And it takes into consideration how above normal the temperatures are at your location. It also takes into effect time of year, the duration of unusual heat, and if temperatures are at levels that pose elevated risk for heat complications. And then here, it is only available in the contiguous US right now. Also, the color scale is calculated for healthy populations with messaging that is there for sensitive populations at a lower color category scale. It also does not directly account for humidity, and it does not account for wind at all. Something else you're probably familiar with are the Weather Service heat advisories, watches, and warnings. So showing the different colors for each of those on a map here. The excessive heat warning is specifically issued within 12 hours of the onset of extremely dangerous heat conditions. So the general rule of thumb for this warning is that when maximum heat index temperature is expected to be 105 degrees or higher for at least 2 days, and nighttime air temperatures will not drop below 75 degrees Fahrenheit. But these criteria do vary across the country, just like a lot of the criteria for the tools that we talk about, whether it is heat, whether it's snow, or other weather. For excessive heat watch, it's issued when conditions are favorable for an excessive heat event within the next 24 to 72 hours. And this is used when the risk of a heat wave has increased, but the occurrence and timing is still uncertain. We also talk about a heat advisory, which is issued within 12 hours of the onset of extremely dangerous heat conditions. And the general rule of thumb here is that the advisory is issued when the maximum heat index temperature is expected to be 100 degrees or higher for at least 2 days, and the nighttime air does not drop below 75 degrees. And then there's one more that is not listed on here, which is the excessive heat outlook. And that is issued when the potential exists for an excessive heat event to be in the next 3 to 7 days. And so this is just giving some lead time for you. So again, very helpful tool for planning. But when we take a look at what's happening today, I actually pulled a screenshot of the homepage of the Weather Service where the watches, warnings, and advisories are. You'll see that there are a lot of current heat warnings, watches, and advisories going on right now, especially in the Pacific Northwest. You see also Northeast Montana, the Southeast part of the United States, parts of the Eastern coast. And so it's still pretty hot out there while we're at the end of July. It's going to continue being warm into August. There are some additional resources outside of traditional Weather Service tools that are helpful. So the National Integrated Heat Health Information System, which is an interagency organization that Morgan is a part of, that's like what her position is under within the Climate Program Office. And also, again, something that I've learned about since being in the role that I have. Recently, we call it NIHIS as well, so I'll refer to it as NIHIS from now on. Recently, NIHIS released 2 new resources to support communities and local leaders with heat planning efforts. So this is showing the cover of the Introduction to Heat Tabletop Planning and Coordination. This describes the steps and timeline necessary for communities to develop and run a heat tabletop exercise. Now, these exercises are allowing communities to test their response to high-impact heat events through simulated exercises so they can identify their strengths and areas for improvement. Then the next tool is the maturity model for heat governance. This presents a framework that leaders and decision makers can use to assess their capacity to successfully manage heat risk across 10 different dimensions. When used over time, the maturity model can help communities track their continued progress towards building heat resilience. And I know Morgan is putting the links in the chat, but if you are watching this later, you could go to heat.gov to download the resources and get more information. Something else that you may have heard of that's good to understand when you're planning for heat are urban heat islands. It's important to know where the hottest parts of your region are, and you can do them by mapping urban heat islands. But first, to understand what that is, urban heat islands are the areas of cities that get warm, a lot more warm than their surrounding rural landscapes, particularly during the summer. And the temperature difference occurs especially in unshaded areas where there's tall buildings, and these areas gain a lot of heat throughout the day. And that heat then radiates into the surrounding area. And it's typically going to produce temperatures between 15 and 20 degrees warmer than the surrounded vegetated areas that have trees. You see, like rural and suburban areas with a lot more trees are going to typically be cooler than in the city region. This is a screenshot of some images from the NIHIS Urban Heat Island Mapping Campaign that occurred in New Mexico, and it's showing how temperature can greatly differ between shaded grass and exposed pavements. So these dark surface areas are absorbing more energy from sunlight than the lighter reflective surfaces. The absorbed energy is released over time as heat energy that we can feel. So if you put your hand on the dark surface that's been in the sun, of course it's going to feel hot. And so that's kind of how it is when you're looking and thinking about cities having to absorb a lot more heat, and why the temperature is a lot different between the city and suburban and rural areas. Also, we know that trees and other vegetation, as well as soil, do help absorb and release moisture. And evaporating water requires energy, which means that evaporation cools the air because heat energy is used for evaporation. And what we see in purple here are the shaded areas, the tops of trees down below where we do have some of the shaded areas, and the pavement being a lot hotter when you look at the scale here in some of the areas that we're seeing reflection from the buildings. But now I'm going to pass it over to Morgan to talk a little bit more specifically about these urban heat island campaigns.
Thanks so much, Amber. So yeah, as Amber mentioned, we have definitely been working a lot on urban heat islands, as I believe the statistic is about 80% or more of Americans do live in urban areas. And so to really address this large portion of the population and be addressing this problem that we know exists in cities, NOAA in 2017 started partnering with a private sector company called Kappa Strategies out of Portland, Oregon, to really do a better look at urban heat islands and look at the heat distribution across cities, because we know that two neighborhoods, even if they're adjacent neighborhoods, may not experience heat the same due to a lot of factors of the built environment, such as taller buildings, having more concrete and asphalt, having less tree canopy, waste heat from cars, and so much more. And so we have been doing this mapping in more than 80 communities across the US, as well as some international locations too. And one of the things that makes this program so unique is it's a community science effort. So it's not your typical government project where scientists go in, collect data, and then leave. It is us partnering with communities, and it's volunteers from all of these neighborhoods who are going out on one day during the summer, typically in the 90th percentile of temperatures on one of the hottest days with no precipitation and very little cloud coverage. And they attach a sensor to their vehicles, and the sensor collects air temperature, humidity,
Morgan, I think
machine learning model. And then they are able to work with this model to then put together this report. And the report outlines where the hottest neighborhoods are, so that communities can then work with their local decision makers to be implementing cooling solutions in those neighborhoods. So I also want to note that all of this data is open access. So not just the reports from the campaigns, but also the raw data itself is available on heat.gov. If you go to our Urban Heat Island tab, you'll be able to find all of the reports from the cities we have mapped. And we have a whole new list of cities that you can see at the top here that are doing some mapping this summer, and many of them have already completed the mapping or are in the process of finalizing it. So it's been really great to see all the really great work that's been done across these cities. And I'll pass it back over to you, Amber.
Thanks so much, Morgan. That's really helpful. And you can also apply for the next round of campaigns, which will occur in 2025, later this fall. You can look out for an application. As you can see which cities have been mapped, you can also see that there are a lot that have not been. So if that's something that interests you and your community, definitely keep that in mind. Now we're going to talk a little bit about heat waves and heat domes, starting with what the difference between the two are. So it's helpful to think of a heat dome as what's happening in the atmosphere, while the heat wave is how the heat is actually affecting people on the ground. And the picture that you see here is the heat dome. So it refers to a ridge of high pressure that persists over a large geographical region and delivers high temperatures that linger on for days or weeks on end. And one of the more famous, more recent heat domes that we think about is the Pacific Northwest, heat dome that impacted the whole Pacific Northwest region in June of 2021. But in general, high pressure is acting as a cap that traps the heat at the Earth's surface and raises temperatures in the whole lower atmosphere. And because hot air actually expands, it creates a bulging dome. And the heat prevents convective clouds from building up, so that reduces rain chances. And it results in continual buildup of heat at the surface, which again is referred to as the heat wave. And so a heat wave can occur without there being a heat dome. But essentially, when we talk about a heat wave, it's a prolonged period of excessive hot weather. And it's oftentimes linked with high humidity that lasts days to weeks. And the Weather Service defines a heat wave of at least 2 consecutive days of high heat risk. So it's not just daytime heat that we have to worry about for the summer and beyond. It's also heat at night, because heat waves are even more dangerous overnight when temperatures are too high to relieve people from heat. That also helps to prolong heat stress and other associated heat risks. And that's according to different health experts. And so this is the infographic that NOAA created, just talking about the fact that excessive heat is still dangerous after the sun goes down. I have a couple of graphs and maps to show from the EPA, and specifically it's talking about heat wave characteristics in the United States by decade from 1961 to 2023. And this is a figure using NOAA data showing changes in the number of heat waves per year. So that's the frequency or the average length of heat waves in a day, being duration, the number of days between the first and last heat wave, so the season length, and lastly, how hot the heat waves were compared with local temperature thresholds for defining a heat wave or the intensity. And essentially the graphs are showing that the average across all 50 metropolitan states by decade are increasing with the frequency, duration, heat wave season, and heat wave intensity. And when we look at this in a map version, it's actually showing which of the cities are seeing more heat waves, longer heat wave seasons, and stronger heat waves. Another big question that people are starting to ask are, why are our summers getting so hot? And this is a picture from Death Valley in California, where there's a sign that says caution, extreme heat danger. Well, in recent years, the average heat wave in major United States urban areas has been about 4 days long. And this is an entire day longer than the average heat waves were in the 1960s. So the timing of heat waves matter, because when heat waves are occurring earlier in the spring or later in the fall, that does catch people off guard, and that increases their exposure to heat-related illnesses. But our longer-term records are showing still, even though that's happening, that the heat waves that occurred in the 1930s are the most severe still recorded in U.S. history. So again, that was during the Dust Bowl, but specifically in the Great Plains region. And so poor land use practices and many years of intense drought contributed to these heat waves by depleting soil moisture and reducing moderating effects of evaporation. But again, we are still seeing that our summers are getting hotter now. And on the climate scale, the reason for this is human-enhanced climate changes, increasing frequency and intensity of these events. And as the effects of climate change are intensifying, our weather patterns are becoming more extreme. The fifth National Climate Assessment actually found that heat waves are becoming more common and severe in the western US since the 1980s. And as I told you earlier, we are seeing that because of larger and more land masses in the northern hemisphere warming up, they're actually, with this human-induced climate change through burning of fossil fuels and emissions of greenhouse gases, they are warming up faster than our oceans in the southern hemisphere are able to cool down. And so that imbalance is creating a warmer Earth and, of course, then warmer summers. So getting into the health impacts of heat, we can see from the World Health Organization on this chart here that there are a variety of direct and indirect heat health impacts. So there's a large scale of how heat is impacting our health. Indirectly, there are increased transmissions of diseases, disruptions and compromises through essential health services and facilities, as well as critical infrastructure and technology. We have environmental impacts and behavior changes. And then directly, we're seeing how heat can exacerbate conditions and mental health illnesses. So these mental health and substance use risks include loss of sleep, slowing of brain cognition, also a heightened risk of increased acute psychiatric and substance use symptoms among people with chronic behavioral health conditions, a variety of heat illnesses, which I'll be getting into in a few more slides. Also, hospitalizations, we're seeing a direct impact there. The CDC reported nearly 120,000 people in the United States visiting emergency rooms for heat-related illnesses just in 2023. And unfortunately, we are seeing deaths because essentially heat is the number one weather killer now. And so when we think about some of the data that I've seen recently, the United States Department of Health and Human Services heat-related deaths have been increasing over the years, especially in 2021, 2022, and 2023, respectively. We had about 1,600 deaths in 2021, 1,700 in 2022, and a bigger jump to 2,300 in 2023. So heat stress, when we get into talking about heat illnesses in the range, you can also hear the word heat stress be used. That is when the body can't get rid of excess heat, essentially. So it kind of ranges from the rash, cramps, exhaustion, stroke. The heat stress is the leading cause of weather-related deaths, and it can exacerbate underlying illnesses, including cardiovascular diseases, diabetes, as I said earlier, mental health, asthma, and can increase the risk of accidents and transmission of some infectious diseases. Now, heat rash, you may have heard it be said is prickly heat that occurs when the sweat is trapped in the skin. And symptoms can range from small blisters to deep inflamed bumps. And some forms of heat rash are very itchy, but not all of them. Heat cramps are muscle pains or spasms that occur in the stomach, arms, or legs. And this is a pretty popular graphic that you may have seen, but has a more specific breakdown of the difference between heat exhaustion and heat stroke. So for heat exhaustion, you may be dizzy, thirsty, sweating a lot, have nausea and vomiting, might have body weakness or high body temperature between specifically 101 and 104 degrees Fahrenheit, and also rapid breathing and increased heart rate. So whether or not you're experiencing these things, if you see someone else experiencing these things, or if you're able to take someone's body temperature and see where that number is, that's important to understand if you're experiencing heat exhaustion. But heat exhaustion can lead to heat stroke. That is where your body temperature is above 104 degrees Fahrenheit. You do have dry, red skin. Another big difference is you are not able to sweat. You may have seizures or slowed speech, confusion, aggression. You might be agitated. You can also become unconscious or faint and have hallucinations. So these are all different signs to be looking out for heat exhaustion, heat stroke. But if you are with someone experiencing heat stroke, it's important to call 911 right away. This graphic is from the 4th National Climate Assessment, and it's showing different populations at high risk of exposure to adverse climate-related health threats, so extreme heat being one of those. So communities of color, children, older adults, and low-income communities are among some of our most vulnerable for climate impacts. When considering the full range of threat of climate change, we not only have to deal with extreme heat, but other environmental exposures. So these are the groups that are most exposed and most sensitive and have the least individual and community resources to prepare. So keep that in mind as we talk about some of our other vulnerable populations. Specific to heat, this graphic shows how pregnant people, newborns, children, elderly, and those with chronic illnesses are among the most vulnerable specifically for heat impacts. But it's important to note that anyone can experience heat illnesses, even while these are the most vulnerable populations. Another really nice graphic here showing about extreme heat in children. So children who might just be going to school, babies and infants, or those who are athletes playing outside. It's really important to remember that these are a vulnerable population. So never leave children in parked vehicles for any amount of time, as temperatures can become dangerously high. And that might sound like, oh, I've heard that before, I already know that, but unfortunately 15 children have died in a hot car already this year, according to National Highway Traffic Safety Administration. So it's something that still should be said. Also avoid direct exposure to sun during peak hours, especially for children. Seek shade or stay indoors if it's possible, because again, shade can reduce how hot you feel by 10 to 15 degrees Fahrenheit. If you are outside with a baby, never cover an infant stroller or pram with dry fabric because it will make it hotter. Instead, just use a wet or thin cloth and re-wet as necessary to lower the temperature, and you can put that wet cloth over the stroller. You can even use a portable fan for even more cooling. And dress your children in lightweight, loose-fitting clothes that covers their skin, and use brimmed hats and sunglasses and sunscreen to help protect them from the sun's rays. For those who are outdoor workers, even if you're in the best physical shape, it's important to keep in mind some of the safety tips when you are working outside, especially staying hydrated. So it's good practice to drink a cup of water every 15 to 20 minutes. So about like an 8-ounce cup of water every 15 to 20 minutes. As much as possible, taking regular breaks in shady or air-conditioned areas if you're able to get somewhere inside or even in your car. And also just monitoring yourself and your coworkers for heat, stress, and illness is important. We talked about people who are older, so 50 and older. Cooling down the body becomes harder with age. Our sweat glands become less effective with age as well. There are several medications that older adults take that the heat can actually interfere with how efficiently those different medications work, which can include antihistamines for allergies and drugs to treat overactive bladders, also diuretic medicines or water pills, and antipsychotic medicines. Those are all impacted by heat. Also, certain antidepressants and blood pressure medicines can hinder the body's ability to cool itself. But another disadvantage for older adults is the specific impact of heat on the heart, because the body releases heat by increasing blood flow to the skin to push the heat away from the core of the body. And this requires the heart to work harder. So if you have heart disease, that actually puts a strain on your already weakened heart. Unfortunately, we do see a lot of older people having heart attacks and strokes during these heat events because, again, they have a harder time staying hydrated for reasons that I just mentioned above. They also have a decrease in thirst as we age. And dehydration is risky for about 40% of U.S. adults that are 65 years old or older who already have kidney disease. So there are some caveats too, like not just everyone who is 50 and older are necessarily the most vulnerable, but again, these are some considerations and the different heat impacts for those populations. And it's not just people who are vulnerable, our pets are also impacted by heat. Now, the American Society for Prevention of Cruelty to Animals has information on pet heat safety. So this is a graphic from the Weather Service giving specifically about pets in vehicles, but you can also be watching for symptoms of overheating pets just regularly in your house or outside, excessive panting or difficulty of breathing, increased heart rate and respiratory rate, drooling, mild weakness in their level of alertness. They may have a seizure or bloody diarrhea and vomit, along with elevated body temperatures of over 104 degrees. That's really showing like heat stress in animals. And if you have a dog or a cat with a flat face, like a pug or a Persian cat, those breeds are more susceptible to heat stroke since they can't pant as effectively. And along with elderly and overweight pets and pets with heart or lung disease, they should all be kept in cool air conditioned rooms as much as possible. And then if you have a longer haired dog, feel free to trim them, but never shave them because the layer of dog coats protects them from overheating and sunburn on their skin. And then for cats, brushing your cat more often than usual can help prevent problems caused by excessive heat, get rid of that excess hair. And if you are going to put sunscreen or insect repellent on your pet, be sure that it is actually safe to be used on animals. So the actions that we can take now that we've, been educated and know how to plan for extreme heat can range before and during a heat wave. So this is the last section, just going through some more tips that you can be taking to educate yourself. So we talked about staying hydrated. That is definitely important to do. Gathering emergency supplies, a go kit and a stay-at-home kit are equally important. Really, if the power were to go out for any reason, it's important to have a cool place to go. So that's why that go kit is important. Also, if you're just happen to be traveling during a heat wave, especially like most of us do in the summertime, you might want to plan to sightsee during the cooler early morning or evening hours to avoid the hottest hours of the day. Same thing with the beach. It's best to go during the cooler times of day. The middle of the day is definitely the hottest, and that's where we're seeing a lot of heat exhaustion and other heat stress symptoms. But you can plan ahead again by keeping an eye out for the forecast and the news, signing up for your local emergency alerts. This is for if you're local to your home area or traveling. And it's also useful to learn emergency skills like first aid and CPR. And some other things you could do specifically to your house is weather strip your doors and windows, adding insulation to keep heat out in general from your house. And also ensuring that the primary cooling device in your house is not a box fan. Now, during a heat wave, these are some more tips from FEMA. When we talk about staying hydrated and learning how to do that, now it's time to put that in practice. So you want to be drinking more water, more electrolytes, staying away from sugary and caffeinated beverages, staying away from a lot of alcohol, things that will dehydrate you. Take cooler showers and baths. Try to use your oven less and avoid high energy activities outdoors. But again, if you are outside, if you have to be outside for sports or work or other activities, trying as best you can to stay in the shade and wear head protection and sunblock is important. And then also equally important is checking on others, your family, your friends, your neighbors, but especially monitoring how you feel. Keeping track that, while you're taking care of everyone else, you also want to make sure to take care of yourself. So that is all we have. And Morgan is going to also be able to answer questions, but we'd be happy to hear if you have success stories to share about combating extreme heat, or if you do have any questions, and this is our contact information.
Thanks so much, Amber, for that great presentation. We already have some questions coming in.
Yes.
Our first question is, any tips on keeping your vehicle cool so that you do not burn your hand on a seatbelt or steering wheel other than parking in the shade?
Yes, definitely. Now, what the formal name of them are, I don't necessarily know, but the different barriers and like shades that you can specifically put in your windshield, I've purchased those before, and those really do help. If you wanted to cover your car, there are like car covers you can also get. Those things do help. And you could even, if you have dark seats, you could put seat covers on, like light colored seat covers. Those kind of things will also help to cool your car off.
Great, thanks.
Yeah.
Another question that just came in, any training opportunities for heat wave analysis?
I do not know of any, but do you know of any, Morgan?
I think that I don't know of any necessarily that like we're helping to promote on, say, heat.gov, but I think it's highly possible that there's different training opportunities through the Global Heat Health Information Network, and I can put that link in the chat. But that's a global consortium of different, not only countries, but also different academic institutions, nonprofits, and such that are working together on extreme heat. And I know that they do a lot of training and modules on different aspects of heat. So there might be some information about more specifically on heat wave analysis.
That's helpful. Thanks so much, Morgan.
Sorry, go ahead, Maury.
Yeah, another question I saw come in was, can you touch on any other impacts besides heat and health?
Oh, sure. So like heat impacts, or I guess whoever asked that question, like, do you mean like impacts on from heat on anything else besides health?
Correct. Yeah. So heat's impacts on other things.
Yes, definitely. One of the biggest, like what we would like, one of the terms that is becoming more popular are cascading impacts. And so one of the other cascading impacts that we've seen with heat is on, as we talked about with precipitation, lack of precipitation, especially during our heat domes, we're starting to see that that is becoming more frequent and leading to drought. And they might just be like micro droughts or temporary, but we are seeing that that is happening. That's another impact.
Yeah, and I'll add on to that too. Heat has a lot of other impacts besides just health. Health is definitely one of the largest ones that we are concerned about, as it does kill more Americans each year than any other weather-related event. But heat also impacts our transportation system. So back in June, there was a heat wave in the Northeast, and we saw there was a major impact to the Amtrak systems with going into Penn Station in New York, that there was cable lines were down, a lot of the engines overheated. So we're seeing this in our transportation system, that railways are warping. If you have been on an airplane this summer, you may have experienced that as well, that extreme heat does, it makes it more turbulent in the air, but then can also impact, again, the roadways and so much more. And in addition to transportation, heat is impacting our agriculture. It's impacting our economy. There are so many impacts of extreme heat in addition to just health.
Yeah, and I started to take that next question I pulled back up the locations that have been mapped. So no, formally from the program, the Urban Heat Island Mapping Program, just Little Rock has been the one city in Arkansas, but the link I just gave was for the mapping campaigns page, and that's what you'll be able to keep your eye on, because there will be opportunities for you to participate in the future. Yes, Urban Heat Island Mapping. Yes, you're welcome. And I am curious if anyone has a success story specific to combating heat health impacts, whether it's like personally or someone you've been able to help or identify. And you can feel free to just type out something, or if you wanted to unmute, you're welcome to do that. And if you do have other questions, feel free to put those in too.
Well, Amber, while we're waiting on potentially people to answer that question, I have a question for you. Do you have any communication tips for extreme heat? What are some quick key messages that people and communities may want to know for addressing heat?
Yeah, that's a great question. Communication tips for extreme heat are definitely that we know heat is the #1 killer of people. So, having that fact, we know that 2023 was the warmest year on record. June 2024 was the warmest June on record. We're probably going to be seeing in the next few days that July 2024 was the warmest. So, knowing what the current state of the heat is, those would be a few of the communication tips. And then also some of the different um, tips that we were talking about towards the end with respect to staying hydrated, monitoring yourself and others, um, preparing by keeping an eye on the forecast. Those kind of things I think are important small tips that people can be sharing with others. And a lot of the resources that I shared were from NOAA, the EPA, FEMA, World Health Organization, World Meteorological Organization. So a lot of these very credible sources. I think if you're a person who's looking for these resources, that you could be going to these credible sources and sharing that, because one of the big keys is that it is important for people in their communities to know this information so that they can be trusted sources in their communities and share that widely.
And I just added to the chat the National Weather Service, and many of the graphics that Amber showed in her presentation are freely available on the link that I just shared in the chat, and that's got all of the different heat-related graphics that the National Weather Service has produced.
Yeah, but that might be all the questions we have for today, and that is completely fine. And I really appreciate everyone's attention and being here this evening, and hope that you've learned something new about heat and health, and that this will help you going forward.
Actually, Amber, I did have a question.
Okay.
I think you mentioned somewhere that box fans aren't really helpful. How come that is so?
So it's not that they're not helpful at all, but they're not helpful to be your only source of a cooling system, just because a lot of times they're recirculating already warm air, so they're not really helping cool down an area.
Gotcha. So just kind of shifting the problem.
Yeah, that's a good way of putting it. But they are helpful to have, like, in addition to an air conditioner. And it's also helpful to use if you do have a box fan, like using it at nighttime once it's already cooled down. So not during a heat wave, but like in a normal night, once things start to cool down, pulling in that cooler air from outside. Those are the times where it's really good to use a box fan.
Okay, that would make sense. Cool. Thank you.
Absolutely.
Well, yes, Amber and Morgan, if you had nothing else. Alrighty, I think, well, in that case, thank you both so very much for joining us this evening.